Now, this is looking at a process called electrolysis, which forms quite a big part of the chemistry GCSE. And electrolysis is a process that's used for a number of different things. So it can be used to electroplate other metals. So for example, if I wanted to galvanize an iron nail so it wouldn't rust outside, I could use electrolysis to electroplate some zinc on the outside of it. I could electroplate jewelry to make sort of cheap metals look nicer. However, the problem with this is that metals that have low reactivity are not very easy to electrolyze. So as a result, the metals that you'd use for jewelry don't really tend to work this well because they tend to be quite low in the reactivity series. You can also use this to get pure metals from impure metals. So this is done sort of in things like recycling. So let's just have a look at the process that goes on. This contains some key words, and you need to know these key words. So you've got an anion, which is a negative ion, a cation, which is a positive ion, the cathode, which is the negative electrode, the anode, which is the positive electrode, and the electrolyte, which is any substance that can conduct electricity, any liquid or molten substance or solution that can conduct electricity. And the reason this works is because if I have an ionic compound, it forms what's called a lattice. And this is when it's solid, and those ions are unable to move. However, when I put them into water or I melt them and they become molten, these ions separate. And now they are actually able to move around. And once they're able to move around, they're able to move towards a charge. And that's what happens here. Now, what's going to happen, I always remember this by starting off with the cation, because cations are positive, but cathodes are not cats, and so we can't say they're positive, but the cation is positive. So the cation is positive, that means the anion must be negative, and the opposites attract. So the positive cation must be attracted to the negative cathode. The negative anion must be attracted to the positive anode. And what's going to happen is these ions that are now able to move around are going to be attracted to the opposite charge. So these cations are going to move towards the cathode, and these anions are going to move towards the anode. And if this is a metal, for example, this metal is going to lose metal ions to the electrolyte, which are then picked up again at the cathode. Now, the reason this works is because the electrons that are donated at the anode by the anions, so the electrons go into the anode, they go around the circuit into the cathode where they get given to the cations, which means that these here turn from an ion into an atom. So, for example, this would be a copper ion, Cu2+, and once it gains the 2 electrons from the cathode, it becomes Cu, just copper by itself, so pure copper, which is why this can be an impure metal with all these different compounds in there, all these different atoms, all these different ions in there, but the copper that you're trying to extract will be pure at the cathode. Now, just sort of go into a bit more detail, you kind of need to know about how this works in terms of half equations. So we're going to kind of ignore what's going on at the anode a little bit, because that's where the non-metals are going to go. And we're going to focus on the metal, because that's the bit that we're really interested in. So at the anode, I've got my metal. Now, it might be impure, okay, and it's a solid. Now, what's going to happen is it's going to lose its electrons, okay, and it's going to form an ion. So in a question, you'd want to be specific about which one this is. So if it's copper, it's copper. If it's aluminium, it's aluminium. But this would form an ion, an M+, and that would be aqueous. And you would then have an electron. At the cathode, that electron is rejoining the metal ion. I don't know why I've called that Me. So M+, that's joining the metal ion to make, which again is aqueous, to make metal solid, which is pure. And it will be a thin layer of this metal on the outside, or a thick if you leave it for a long time. And if this is let's say copper, for example, that would be CuS, would give you Cu2 plus, because it would have a 2 plus charge. And if this is a 2 plus charge, this is 2E minus. So for every positive charge here, you get an electron. So if that's 3 plus, that's 3 electrons. And it will be the same over here.